So welcome back, grade 12s. Today we're looking at sections 3.2, the remainder theorem. Once again, I encourage you to look at the focus on section at the beginning of each one of the topics that we study in Math 12. Today we're looking at the relationship between polynomial long division and synthetic division. We're going to use long division and synthetic, try saying that a few times, and synthetic division to divide a polynomial by x minus a. And we're going to explain the relationship between the remainder when dividing by x minus a and the value of a polynomial at x equals a. So just a quick reminder of some language. If you look at long division over here on the left, we're kicking it back old school here. We're looking at a dividend, 327. It's being divided by a divisor, which is 12. The answer to a division is a quotient, 27 in this case, and sometimes, often actually, we get a remainder of 3. So just to remind you, when we divide 327 by 12, we're looking for how many times 12 goes into 32. That's twice. 2 times 12 gives us 24. We subtract those numbers, so 32 minus 24 is 8, and then we carry down the 7 to get 87. Now we ask, how many times does 12 go into 87? Well, you might have to play around with that a little bit, but it's 7 times. 7 times 12 is 84. 87 minus 84 is 3. And then 12 can no longer go into 3. So that's our remainder. There's nothing to carry down here. So we're left with a remainder of 3. On the right in red, we've got polynomial long division with the same content. We've got a dividend, a divisor, a quotient, and a remainder. And first we're going to look at how do we do long division with polynomials. So in our first example, we're going to divide 5x cubed plus 10x minus 13x squared minus 9 by x minus 2. So the first step is we need to rewrite the polynomial in decreasing order of the degrees here, the exponents. I'm going to start with 5x cubed and then minus 13x squared plus 10x minus 9. So we want the exponents to get smaller, and if there is a missing term, we have to write that in. So let's say it was 5x cubed minus 13x squared minus 9 and there was no 10x. It would be important here to write a 0x. So I've got the polynomial in decreasing order of exponents, and then I'm going to divide that by x minus 2. The question I ask myself is, what do I need to multiply x by to get 5x cubed? Well, the answer to that is 5x squared, and I write that above here, above the other x squared term. Doesn't really matter where I write it, but I like to do that so it helps me keep things in order. Now, to get the next line, I go 5x squared times x. That's 5x cubed, as we know. And then 5x cubed times negative 2. We have to do that as well. And that gives me negative 10x squared. Now I'm going to subtract those two binomials, those terms. The 5x cubed are guaranteed to cancel out because I created something that was going to make that happen. So 5x cubed minus 5x cubed is 0, x cubed. Negative 13x squared minus negative 10x squared is like saying negative 13 plus 10, or negative 3x squared. I bring down the 10x, and then I start the process over again. What do I multiply x by to get negative 3x squared? Well, that has to be negative 3x. Negative 3x times x is negative 3x squared. Negative 3x times negative 2 is positive 6x. And remember, we're subtracting those. These guys cancel. And then 10 minus 6 is going to be 4x. Bring down the negative 9. And we start the process over again. What do I have to multiply x by to get 4x? Well, that has to be a positive 4. 4 times x is 4x. 4 times negative 2 is negative 8. And negative 9 minus negative 8 is like saying negative 9 plus 8, or negative 1. Now there's a form that we can use to express the answer to a polynomial long division. And what we do is we take, let me find my highlighter here, we take the polynomial divided by the divisor. That's going to give us our quotient as a function of x plus the remainder divided by the divisor again. Looks more complicated than it is. Basically what we're saying is we take the polynomial, so 5x cubed, we're dividing that by x minus 2. That's going to be equal to our quotient plus our remainder, which is -1, divided by the divisor. Now because we're talking about a division, there are some possible restrictions here. And it's important that our divisor not be equal to 0. So the restriction on this, and we've talked about restrictions before, the restriction is that x minus 2 cannot equal 0. And that means that x cannot equal 2. So as long as x is not equal to 2, then we're fine. Now how do we check? I mean, this thing, it's a way of expressing our answers. But how can we write a statement that helps us sort of verify that things are true? Well, if 5x cubed plus 10x minus 13x squared minus 9 divided by x minus 2 is this, plus the remainder, then it should be true also that 5x cubed plus 10x minus 13x squared minus 9 is equal to the quotient times the divisor plus the remainder. So let's check that out. 5x squared times x is 5x cubed. 5x squared times -2 is -10x squared. 1. 5x cubed stays the same. There's no like terms there. -10x squared minus 3x squared is -13x squared. Looking good. 6x plus 4x is positive 10x. That's also looking good. Oops. 6x plus 4x. Did I write the question right? No, I didn't. This was actually 10x. Right up here. Plus 10x. Oof. And minus 8 minus 1 is minus 9. And that's exactly what we had. So we checked our answer. We took our polynomial, the dividend, and made it equal to the quotient times the divisor plus the remainder. Now there's another kind of division that we can use with polynomials called synthetic division. It's newer to you, so when you see it the first time you might think, it's a little bit more complicated, but truly I tell you, it is easier and faster by far than long division. Here's how it works. Let's use, for the sake of the example, the same question. So once again we're going to divide 5x cubed plus 10x minus 13x squared minus 9 by x minus 2. And this only works, by the way, in the form x minus some number or x plus some number. So I start with this kind of long t section here. And what I do is I write the coefficients of each of the terms up high here in that decreasing order of exponents. So I'm going to have the 5, I'm going to have the -13, the positive 10, and the -9. I'm dividing those by, what am I dividing by? I'm dividing by x minus 2, so I'm going to have a -2 out here. So first thing I do is I take the leading coefficient and I drop it down. Then I go -2 times 5 and I write my answer up here. From this point on, I'm going to subtract the bottom number from the top. So -13 minus -10, that's like saying -13 plus 10, is -3. -2 times -3 is 6. 10 minus 6 is 4. -2 times 4 is -8. -9 minus -8, that's like saying -9 plus 8, is -1. The last number is always the remainder. The other numbers are the coefficients of the terms of the quotient. And by that I mean, if this was an x cubed in the question for the dividend, then in my quotient I'm going to have 5x squared minus 3x plus 4 with the remainder of -1. And if we look back at the previous question, 5x squared minus 3x plus 4, we've got exactly the same answer. 5x squared minus 3x plus 4. In what I believe to be a significantly faster way. So I'm going to put another question up with synthetic division, and let's try that again. So this time let's divide x cubed plus 7x squared minus 3x plus 4 by x minus 2. So again, we draw our little t. We write down the coefficients of each of these terms, and they happen to be in order this time. So 1, 7, -3, and 4. We're dividing by x minus 2, so I'm going to have my -2 out here. And a reminder that we're going to be subtracting terms. So we drop the first one down, 1. -2 times 1 is -2. 7 minus -2 is like saying 7 plus 2, or 9. -2 times 9 is -18. -3 minus -18 is like saying -3 plus 18, or 15. -2 times 15 is -30, and 4 plus 30 is 34. So there's our remainder, and our quotient would be x squared, 1x squared, plus 9x, plus 15, with a remainder of 34. Lastly, let's take a look at what's called the remainder theorem. This will be example 3 for us. Basically, the remainder theorem says that for any polynomial, and let's just use the previous one here from example 2, that for any polynomial divided by some divisor in the form x minus a, that if I take the value of a and substitute it into the polynomial, the result of that, when I simplify it, or when I evaluate the polynomial for 2, the result is the remainder. So let's see if that happens here. I take the 2 and replace it with in the place of x, so I get 2 cubed plus 7 times 2 squared minus 3 times 2 plus 4. Notice I didn't plug in -2. I plug in the value that comes after the negative sign. 2 cubed is 8. 7 times 4 is 28. 3 times 2 is 6 plus 4. So 8 plus 28 is 36. 36 minus 6 is 30. And 30 plus 4 is 34. The same remainder that we had when we did the synthetic division. Where this is useful, we'll see shortly in the next section, but where this is useful is when we get a remainder of 0. If I can check a solution and know that I divide, or when I substitute the a value here, the 2, into this polynomial, if I get a remainder of 0, then I know that this divisor is a factor of the polynomial. And that becomes very useful, and we'll see that in the next section. Okay, so that's it for now. Take a look at those questions, those examples. Read through your textbook in section 3.2, and we'll see you in class tomorrow.